let's get started. So I'll mostly show a live demo, but I'm going to start with a couple of blog posts that we'll use as an introduction to what InfoDrainage is and the main capabilities. And we'll look at the difference between standard and ultimate as well. So if we start with this blog post, this will be shared with you, by the way, at the end of the webinar with the recording. So you will be able to look at those in a bit more detail if you want. So this one is mainly an introduction to what is InfoDrainage. It's a drainage design software platform to design storm and file networks, and we'll look at all the main features that we have. We'll look at the initial assessment. You can simulate overland flows. You can apply a certain amount of rainfall and see what the natural flow of water would be without any drainage to get an idea of where the drainage may be needed and the storage may be needed. There are some tools to calculate the storage that's needed for an initial estimation. We'll have a look at that as well. When creating the network, we have a number of connections and junctions that you can use. You can create your own manholes. You can use different connections, not just pipes. You can use a channel. You can use things like swales, porous pavement, cellular storage, so a number of options there. We'll look at the design flows and the different methods that we have to select the design flows, analysis tools, both 1D and 2D tools, different reports that we can generate, like the manhole schedule, for instance, with the schematic. We'll look at that. We'll have a quick overview of foul networks as well. So the main part of it will be storm networks, but we'll look at foul networks as well. You can import and export from Microdrainage, and we'll look at the Civil 3D integration as well, exporting from Civil 3D and importing from Microdrainage into Civil 3D. You can import into a new file, or you can update an existing file, and it will add, remove, or modify any existing element in the Civil 3D drawing. I also want to talk about the two different licenses, if you want, that you have for InfoDrainage, the two different tiers. You have InfoDrainage Standard and InfoDrainage Ultimate. There are two main differences between the two. One of them is the 2D analysis that we'll look at later. That's only available in the Ultimate version. You can evaluate the flood risk to property or people during an extreme event, and it will display in plan the depths and the velocities of the flow of those exceedance flows. So that's one feature that you would need Ultimate to access that. And another one quite important if you use Civil 3D is the Civil 3D integration. In the Ultimate version, I'll show you in a minute, you have a dedicated ribbon in Civil 3D where you can export and import between Civil 3D and InfoDrainage with the click of a button. With InfoDrainage Standard here in this post, I show some methods, but it's a bit more manual. It requires some manual input, and it's a bit longer and more error prone if you want as well. So I show some possible workflows using some intermediate files like land XML format or things like that. And there's a video at the end. The video shows the workflows in Standard and in Ultimate, so you can get an idea of what would be the difference between the two. Okay, so with that, let's start with the live demo. I have a Civil 3D drawing here. I have a surface. I have a pipe network with some pipes and structures. We have some pipes and manholes here. and we have the catchments as well. We're going to bring all of those to InfoDrainage. So let's say that we started the design in Civil 3D. Now we want to export that to InfoDrainage to continue with the hydraulic design. So I can click on this button in the ribbon. We have an InfoDrainage ribbon. Again, this is the ultimate version, remember? Otherwise, you don't have access to this. You want export to InfoDrainage. So we pick that button. We get the dialog. We browse to the location where we want to save it. So let's save it here. Let's call it InfoDrainage webinar, for instance. Save it with that name. Continue to the next step. I can select here the pipe network that I want to share. I can share the surface as well, and the catchments will also be exported to InfoDrainage. I continue to the next step. And here in this last step, what I'm going to do, I'm going to match the Civil 3D pipes and structures to the corresponding elements in InfoDrainage. So here, because I've done it before, it will remember the mapping. So you can see it's automatically picking the mapping. So if you're doing it for the first time, you may need to do it manually. But one thing you can do, you can create your own templates. So you can save a template with the pipes and structures that you use. You can have all of them in that template, and you simply load that template for future projects. If you're doing it again for the same drawing, if you're importing and exporting multiple times between Civil 3D and InfoDrainage, it will automatically fill it as it's happening here. Okay, so we pick that mapping, we finish. We give it a few seconds and it will generate the InfoDrainage file. Okay, so now that we have the file, let's go to InfoDrainage. I go to open and I browse to that location and open the file that I just generated from Civil 3D. And you can see the pipes and structures, you can see the catchments. The surface is not displaying at the moment, so we can have a look at the display settings. We can pick the minimum and the maximum levels here. You can pick the colors that you like, if you want to show contours or not, different visibility options. Let's leave it like that. And we're going to start with this Deluge feature. In the preliminary sizing, we have this option here. What this does, you can apply an amount of rainfall constant to the whole surface, and it will simulate the overland flow patterns. It will show you where water would accumulate in that surface. So I'm going to pick the options here. You can pick the Manning's number by picking the type rural or urban, or you can specify the Manning's number directly. The area of the element for the calculation, the depth and the analysis time in hours, that's around 2 minutes. So we click OK. And it's going to simulate that flow. Let's look at the display of that. We can control that. So again, similar to what we did with the surface, we can pick a minimum and a maximum. You can again modify the colors. Something that's useful is this restrict to minimum. So if you do that, it will not show anything below the minimum, which is useful to eliminate depths that are too small. So we can see here a bit more clearly where the water would accumulate. We have a bit darker color, so we have a bit more accumulation there. So it gives you a good idea. And those are arrows that are a bit small here to see them, but those are arrows indicating the direction of that flow. Okay, we're going to start by looking at the different options for the display as well. We have this text, it's probably a bit too big. Let's modify that. If I go to plan here, let's make it a bit smaller, perhaps 5. And the icons, you can make them smaller as well. You can also control the different layers. So if I want to show the labels, for instance, for the junctions or not, you can see them showing or hiding. So you can control those, the colors, a number of things there. Let's add some flow paths. We have 2 flow paths here. We're going to call that south, that pipe network branch, and that one can be the north branch. So I can go here and add. Pick the start, pick the end, and then I can rename here. Let's call that south and create the other path from here to there. And let's call that north. Okay, so we have those 2 paths defined. For the catchment areas that were imported from Civil 3D, if I have a look at the settings, in one of them, you have a number of methods to control the runoff, and it's picking those parameters from the Civil 3D file. So if you have them defined in Civil 3D, it will read those values from there. Okay, I'm going to leave it like that for this example. And I'm going to start with sizing the pipes. So I'm going to size the pipes for a 1-year return period. At the moment, if I have a look at the profiles, coming from Civil 3D, I have a constant diameter of 225 for both the south. And if I go to the north, it's going to be the same thing, 225. Okay, so I'm going to size the pipes now. I'll go to this preliminary sizing ribbon, to the wizard. I'm going to pick the south path because the north path is connecting to the south here. It's also showing as a branch. So we pick the south path. We're going to pick the UK modified rational method for the peak flow calculation. And we're going to create the rainfall here. Let's pick FSR. You can see the other methods there. Click on the plus button to create the rainfall. I can call it my FSR, for instance. And then you can pick for England, Wales, Scotland, and Ireland from the map. If I go to the map, you can pick from England, from Ireland, you can pick a point on the map. Okay, so then it will show the parameters here, or you can directly type the parameters if you want. I'm going to pick those parameters, for instance, and I'm going to pick both summer and winter for the storms. I can then add the return periods. Let's add 3. And let's say 1, 30, and 100. And I'm going to add a 20% increase rainfall due to climate change for 100. I can pick the durations of the storms. We can see the durations here in hours. I'll pick the default durations. So we're just going to pick those durations, 9 in total. So we click OK. We have our rainfall defined. We're going to do it for 1 year for that pipe sizing. Continue to the next step. Here a number of options. It will size the pipes and it will modify the slopes if needed as well. You have options to lock the slopes if you don't want to change the slopes or the levels. You pick the size of the pipes. So here you can pick the diameter. So here we have 100, 150, and then after that every 75 millimeters. So 225, 300, and so on. For the manholes, you can also control, depending on the size of the connection of the pipe, it will resize the manhole accordingly to the diameters, according to whatever you specify here. Again, you can save templates of this as well, and then you can load them. If you want to level the soffits or the inverts, if you're changing the levels of the pipes, you can also allow backdrops over here. I'm going to pick those options so that it resizes the pipes if needed. We can continue. And here it will display in orange all the values that have changed. So you can see that the diameter was 225 for all the pipes. Now some of them are smaller, some of them are bigger. We have a warning sign here because we're going beyond the maximum slope that we specified previously. So we will need to revisit that, perhaps change it manually. For now, I'm going to keep it like that. We finish. We get the results. We can see the capacity of the pipes, the flow that we have, the velocity, depth, and so on. If I have a look at the flow paths now, we can see that it has changed. We have more gentle slope if you want, leveling the soffits. Okay, so it has made those changes and it has changed the size of the pipes. Okay, so now that we have those pipes with the right sizes and slopes, let's do some analysis. We're going to do some flood analysis for a 30-year storm. Let me go to the rainfall. And I'm going to change it to a 30-year storm. I'm going to untick the other two. Let's go to the analysis. We can start with the analysis criteria. I can include all the storms. So we added those 9 different durations, if you remember, storm and winter. So that makes the 18 storms that we see here. Okay, so we're picking those 18 storms, and it will calculate it for all of them at once. So if I have a look again, the return period, I'm using 30. I can access it from here as well. I have a flood risk margin of 300 millimeters. So if it gets to that level, so it doesn't flood, but it's within those 300 millimeters, it will indicate that we are at flood risk. If it floods, it will indicate that it's flooding, and if it's below that, it may be surcharged, but not getting to those 300 millimeters. So it will indicate when we get the results. So that's okay. We can validate the analysis. So before starting the calculation, we can double check everything's okay. So all good. We can now continue to go and start the analysis. And we have the results here. Where the capacity is exceeded, it's highlighting them in red if you have this button here. You can also show the critical storm. So for each element, it will show the critical storm. If I make that a bit bigger, you can see that those are surcharged, but we don't have flood risk, or it's not flooding for any of them. You can see the capacity, the maximum flow, the velocity, the ratio of flow capacity. So you can see if it's greater than 1, then you're going over the capacities. You can see those results there. We can have a look at the profile. You can see in red where the flow is going beyond the capacity as well in plan. If I look at the profiles, you can see it's surcharging and it's getting to that level. Okay, so we are not getting to those 300 millimeters of flood risk that we have here. We specify that during the calculation. We can look at more results. If I go to the results ribbon, I can look at junctions. And I can see those are surcharged. Discharge volume, the outflow. So you can look at the different elements. You can go to the critical storm for all of those, and it will show you which storm is it, the duration, and if it's a summer or winter. So it will simulate all of them, and then you can filter by the critical storm, or you can see them individually, one by one, if you want as well. You can generate a manhole schedule. So if I pick this one, you have a number of options here. You can add the schematic. So it will, if I make that a bit bigger, it will show the pipes going in, pipes going out. You can customize those columns, and then you have a number of options here to export to AutoCAD, to a CSV file, if you want to see that in Excel. So there's a number of options there to export the report or print it directly. Okay, so we did that 1D analysis. If you want, let's look at adding some storage. We're going to add a pond. So I'm going to pick a pond here. I'm going to drop it there manually, and I'm going to draw it. You could as well, if you had that drawn in AutoCAD or Civil 3D, you could import that outline. I'm going to do it just manually for this example. I'm going to add another pipe here to connect to that. Let's add a pipe. and connect it there. And I'm going to add that pipe to the flow path that I had. So I edit, and I'm going to add that so that if I now look at the profile, it's getting to that pond. So I'm adding that new pipe, and I'm going to change the diameter. It's adding as 100. I'm going to add it as 375, which is the diameter of the previous pipe, so that it continues with that diameter. Okay, so we added that pond. Let's look at the tools that we have to control that storage of that pond. Okay, so double clicking on the pipe, on the pond, sorry, will access the settings. We can add a depth, let's say 1.5 meters, for instance. It's going to show the pond there. We can add different rows with different depths and areas at those depths. I'm going to start with a constant area. It's going to look like this. If you want, you have some tools here to help you with that. The sizing calculator. So I can pick that. And let's say that I want to add a side slope of 1 and 3. And I want to maintain the top area. So that's going to work out the area that I need at the bottom, and it will display like that. I can add a freeboard. Let's say that I want 300 millimeters of freeboard there, so it's adding it that graphically. Let's go to the sizing calculator again. And what I'm going to do, I'm going to estimate the storage that I'm going to need. So based on the rainfall that I have and the parameters that I'm going to use now, I'm going to estimate that storage. So I can pick that. I can design to the freeboard. So I'm going to only use that storage to the freeboard for the calculation. I pick that calculator. I use the plant data that I already have defined. And let's say that I want a discharge of 10 liters per second constant from that pond to calculate the storage. We can add a safety factor to reduce the infiltration rate according to UK standards. I calculate, and it will give me a range of the storage that's estimated. And if I click OK, it's going to pick the average value between those two. And it's going to resize the pond accordingly. I can add a Manning's number for the pond, for the flow along the pond. So I'm going to type a value there. I'm going to add the outlet. I pick the plus button here, and we have a number of outlet types. You can see here, you can have a weir, you can have an orifice, a pump. You can add the depth and flow graphic if you want. I'm going to add the hydro brake outlets. I'll pick a design depth of 1.2. So 1.5 minus that freeboard. 1.5 was the total depth. The design flow, it was 10 liters per second. We have the criteria for the calculation. Let's minimize the upstream storage requirements. We calculate that. And it will give us the depth and outflow graph for that outlet. Okay, so with that, we have defined our pond. When I click OK here, you'll see this resizing a little bit. So it has adapted to that volume and those dimensions. And we're going to perform the analysis again, this time with the pond. So I can go to analysis one more time. We can double check analysis criteria. $30 years for the return period again. We can validate, make sure everything's okay. You can directly go to the analysis and it will give you a warning if something's wrong. You can validate in advance if you want as well. We give it a moment. So it's calculating those 18 different storms. And we can see here for the pond, the percentage available. If I go to the critical storm, it's 6 hours summer in this particular example. So if I look at the status, it's okay. And we have a 9% available. So we could potentially make the pond a little bit smaller. But 9% is sort of okay. So we can leave it like that, but you can do multiple iterations of that, of course. But you can see that is pretty close with the initial estimation. Okay, we can look at all the results if you want. So we can look at the connections. We can look at the critical storm. Capacity exceeded will be showing in red. So similar results to what we had before without the storage. Okay, so that was 1D analysis if you want. We're going to have a look now at the 2D analysis. So you can simulate the flood risk to property or people for an extreme event. So in the analysis, let's start by picking the 100-year return period. This time, let's pick 100. And let's do the 2D analysis. This one is, again, only available in Ultimate, so you would need that for what I'm about to show now. Let's pick the parameters. Let's say urban, the size of the element. Let's pick the rainfall, my FSR that they defined previously, 100. And you can select the storm. Let's do 15 minutes summer, for instance. We click OK, and it will start the calculation. And it will give us for that extreme event the depth and the velocity of the exceedance flows in plan. We can see the pond is okay. We have 35% available for the storage. And we can see here in plan those exceedance flows. Let's fine tune the display a little bit. We can look at the depths. I'm going to start from 0 to 0.1. That works well here. We can see the colors and the depth times velocity. That's the color of the arrow. So there's a number of arrows there. I'm going to zoom in later so you can see those better. So let's say that we want 0.3 as the maximum here. to control the color of those arrows. Okay, so let's leave it like that. Let's add legends for the depth and for the depth times velocity. And if I zoom in a little bit, we can see the exceedance flows from those two manholes, and we can see the arrows with the depth times velocity. So if you notice, when I hover over a place in plan, over location, it will show over here the individual numbers. Okay, so you have the colors, but you have also the actual numbers there in that area. Okay, so we did those calculations. We made some changes in the slopes, in the pipe sizes as well. Now we want to bring that back to the Civil 3D drawing. Let's save the drawing. And then I go back to Civil 3D. And I'm going to import. Let's select the file. You can pick the network. We only have that one. We can pick the surface. We can use the existing Civil 3D first surface because we didn't make any changes and we already have it there. Otherwise, you can bring the surface as well. And here we have the mapping from InfoDrainage to Civil 3D. This time is empty. I'm going to open a template that contains those mappings. So if I go here, it will load them automatically. So for connections and for junctions. So connections will be pipes in Civil 3D. The junctions will be the structures. We finish. It will give us the option to delete the old data or make changes. I'm going to update what needs changing and add any new elements so that we get the updated network. We can see the pond here. So everything will be added as pipes and structures. If it's not a pipe or a structure, it will be added as feature lines and surfaces. So if I have a look in Object Viewer in Civil 3D, I can see the pipe network. We can see the pond there as a surface and two feature lines, one on top, one at the bottom. Okay, so that's sort of how the whole process would look like of starting in Civil 3D, making some changes in InfoDrainage, and then come back to Civil 3D. Before I show you the file design, let me quickly open another drawing that contains other elements as well. So if I go to this one, instead of just pipes and manholes, here we have some other elements. We have some swales here. We have a swale over there. We have some cellular storage. We have a pond here. We have a bit of a more complex network if you want. You can look at that in 3D. There's a 3D view in InfoDrainage as well. So I can look at that in the 3D view. Okay, so if I'm looking from the top, so that's why I'm not seeing anything. You can see here the different elements in the 3D view from InfoDrainage as well. So yeah, you're not limited to pipes and structures. You have channels, you have those elements, cellular storage. infiltration trench. So yeah, a number of options there. Okay, let me, if you want, I can import that to Civil 3D as well, so that you see how that looks. It's going to be sort of similar, but this time we have some extra elements. Let's do it on an empty drawing this time. Let's select that. Quickly. You can add multiple faces in InfoDrainage. Here we have multiple faces. You don't need to import all of them. So faces, it can be different stages of the design if you want. So you can have multiple networks in the same InfoDrainage file. So it's automatically loading those. We can finish. Or you can use a template as usual. And it will load that to Civil 3D. Okay, so if we look at the resulting file, we can see the catchments, the pipes, the structures, the swales, and all the other elements as feature lines and surfaces. I can have a quick look in Object Viewer. And I can see here how it looks in Civil 3D. Okay. Let me show you a file network as well. If I open that. This one is a file network. We overlaid an aerial image here as well. We have the catchments. So here in InfoDrainage, you have storm and foul. You have both phases. It can be a storm or it can be foul. Okay, you have the option to switch from one to the other one. So you can switch to storm or switch to foul and go from one to the other one. And here, I'm not going to go through the whole thing again, but I'll show you some of the differences. If I show a catchment, you can add industrial flow, domestic flow, different methods. You can add flow per dwelling, so flow per person, flow per dwelling, and the peak flow, and it will calculate the flows like that. Or if you want, the alternative would be to pick the different appliances and pick the number of appliances of each type that you have. So you have 20 wash basins here. We have a shower, kitchen sink, and so on. So you can pick in a bit more of a detailed way if you want by appliances, or you can pick a flow per person and do it that way. In the design options, if I go to the wizard, in the design options here, you have the 1/3 proportional velocity method for the UK. So just wanted to mention that. You have other methods as well. So that about file networks. And the last thing I want to show, I'll go back to the browser. This is a post from Autodesk with the main differences between InfoDrainage and Microdrainage. So if you're a Microdrainage user, 10 things that you can do better, or you can do in InfoDrainage that you couldn't do in InfoDrainage in Microdrainage. Sorry. So yeah, I'll simply go through those quickly. You can, again, we'll share this with the recording, so you can have a look at those in a bit more detail. If you have SADs, so sustainable drainage structures, you can represent them more accurately in InfoDrainage. You have sort of a comparison here. You don't need dummy pipes or dummy nodes. You have those elements that can be added to the drainage network. You can reconnect sub-catchments. So if you have a catchment connected to a structure and you want to connect it to a different structure, you can easily do it in the InfoDrainage. Sorry. You have the Civil 3D integration that we've seen with round tripping, so you can iterate multiple times. You can go from InfoDrainage to Civil 3D, back to Civil 3D, back to InfoDrainage, and it's simply using those two buttons, and you can have your mapping of the parts between InfoDrainage and Civil 3D, and you can simply load that every time. For international projects, if that's something that you use, you have a number of random methods for other countries as well that you can select. If you have something more complex, more ramifications, you can have loops and stuff like that in InfoDrainage. The inlets and outlet structures, you don't need dummy pipes. You have the different phases, so this is what I sort of mentioned. You can have different drainage networks. You can have foul, you can have storm, or you can have several stages of storm, for instance, in the same file. You can compare different scenarios. You can model rainwater harvesting tanks. You have the validation before the analysis. So before you start the analysis, you can double check if everything is set up correctly, and you have the chance to correct it before you get an error in the simulation. And you can create templates for your objects. So you can create your own catchments, for instance, with the parameters that you use, and simply load that. Or you can create custom manholes, stuff like that you can do. So yeah, you can have a look at this in a bit more detail later if you want. Again, we'll share this one along with the other two posts that I showed at the start with the recording. And with that would be the end of my presentation. So we have a little bit of time for any questions, perhaps.
Yeah, Enriquez, we can address any questions anyone has through sending an email to myself there. So you can see my contacts information there on the screen. So if you wish or think of any questions over the next few days, feel free to reach out and we'll address them. And thanks to everyone for attending there today. It was great to have you all here. And Enrique, thank you for your insightful presentation. It's great to get a good overview of the software.
Thank you.